is equation number 6. That is, find the value of K if matrix B and matrix A are inverse to one another. Meaning A is the inverse of B and B is the inverse of A. We have unknown K in this equation. Okay, in matrix B, we have negative K over 2. Now, the question is how to find the value for K. Given A and B, they are inverse to each other. Alright, there are many ways you can solve this problem. One of them is by finding the inverse of matrix A and then compare that inverse with matrix B. Okay, let's do that first. Okay, to find A inverse, okay, first we need to find the determinant of A determinant, or the determinant of A, that is equal to A times D is 2 times negative 3 minus 4 times negative 1. Okay, we have negative 6 and we have plus 4 there, and this is equal to negative 2. So the determinant of matrix A is equal to negative 2. Okay, therefore, now we can write the inverse of matrix A is equal to 1 over the determinant of A, that is 1 over negative 2, multiplied by, now A and D, we change the position. We have to write 2 over here and negative 3 at position 2, 2. 4 and negative 1, we have to change the sign. 4 now is positive, becomes negative 4. We have negative 1 there, so we have to have 1 over here. Alright, now let's simplify and multiply negative 1 over 2 inside. What we have, 2 divided by negative 2 is negative 1. Negative 4 divided by negative 2 is positive 2. 1 divided by negative 2 is negative 1 over 2. And negative 3 divided by negative 2, we have positive 3 over 2. Yeah, that's the inverse of matrix A. And we are given that the inverse of matrix A is equal to matrix B. Okay, therefore, this is the same as matrix B. That is negative 1. Matrix B, we have at that position negative 1. We have 2 there. We have negative K over 2. And we have 3 over 2. Okay. Now, we want to compare between this matrix, and between this matrix. Okay, between left and right hand side. Okay, so the unknown K is at this position. So we have to compare that value with this value. Okay, let's compare. Negative 1 over 2 is equal to negative K over 2. Now, can you tell me what is the value for K in this case? Very obvious that K is equal to 1, right? Very obvious that K equal to 1 without doing calculation. Or if you like, you can do, what we call a simple calculation here, cross multiply, or we call it multiply 2 on this side, multiply 2 also on that side. What we have 2 will cancel. We have negative 1 equal to, this 2 also will cancel, negative K. Therefore, K equal to 1. Okay, there we have it, the value for K in this problem, K equal to 1. Or we can do it in another way. Since it is mentioned that A and B, they are inverse to each other. Okay, we have a fact concerning this what we call this information, this statement. That is, a matrix, when we multiply it by its inverse, that is, for example, like in this case is A inverse, must equal to, we multiply A inverse by A, this will equal to matrix identity. Meaning to say, a matrix multiplied by its inverse is equal to matrix identity or identity matrix. Therefore, since B and A, they are inverse to each other, when we multiply matrix A multiplied by B, we supposed to get identity matrix because A and B, they are inverse to each other. Now let's multiply A and B together and then we compare it to identity matrix. So A is negative 3, we have 4, we have negative 1 and 2, multiply by matrix B, that is negative 1, we have 2, we have negative K over 2, and we have 3 over 2. Alright, let's multiply them together and see what we get. 3, for the first component we have 3 minus 2k. Okay, I hope you understand how I get 3 minus 2k. Over here we have negative 6. Negative 6 plus 6, we have 0. You should understand why I get 0. Okay. At this place we have 1 times negative 1 is 1. Okay, we have 1 minus k. You should understand why I get 1 minus k. And the last number will be negative 2. Okay, negative 2 plus 3 is equal to 1, like this. That's what I get after I multiply A and B together. Now, since A and B, they are inverse to each other, with this solution or this matrix supposed to be equal to, as I mentioned previously, it must be equal to identity matrix, that is 1 0 0 1. Now, if we compare these two matrices together, that is this matrix with the identity matrix, this one, we can compare, correspondingly. Meaning to say, we can compare this number with that number. And also, we can compare this number with that number. Okay, we can choose either one. Maybe I like to use this one, 1 minus k. 1 minus k equal to 0. Therefore, we will get k equal to 1. That's right. Or maybe you want to use 3 minus 2k. Yeah, 3 minus 2k equal to 1. 2k minus equal to 3 minus 1 is equal to 2. So k equal to 2 divided by 2 is equal to 1 also. Okay, so that's the way how to find the value for k. In this example, we show 2 ways to find it. Alright, now this is question number 7. Find the value of k if matrix D is a symmetric matrix. Oh, sorry, because I forget to make correction here. It's supposed to be matrix D, right? So if D is a symmetric matrix, this condition must be fulfilled. That is, D must equal to matrix D transpose. That is, if we transpose the matrix, it will be equal. It will be the same as the original matrix. Okay, we can do many different ways to solve this problem. That is to find the value for k. Maybe the first one we do like this. Okay, since given that matrix D is symmetric, meaning matrix D is symmetrical, okay, about the main diagonal. If this is the main diagonal, this is the main diagonal, these three numbers here in the main diagonal. Okay, if the matrix is symmetric, it must be symmetrical about this diagonal. Meaning to say, this number 2 must be equal to that number 2. Okay, this number 6 must be equal to that number 6. Now, this element here, that is k minus 1, must be equal to number 2. So that's the equation that we are looking for. That is, k minus 1 must be equal to 2. Therefore, k is equal to 3. Okay, that's the answer for the value of k. Or maybe now we can use this equation here. That is, if D is a symmetrical matrix, D must be equal to D transpose. Now let's find D transpose first. What is matrix D transpose? Okay, remember how to do transpose of a matrix? We just change between row and column. Row number 1 becomes column number 1. Columns number 2 becomes row number 2, something like that, you know. Okay, so let's do a D transpose. Okay, D transpose will be, we have 1, 2, 2. Column number 1 becomes row number 1. Columns number 2 becomes row number 2. We have 2, we have 3, and we have 6 there. Now, column number 3 becomes row number 3. We have k minus 1, we have 6, and we have negative 2. All right, that is D transpose. Now, if matrix D is symmetric, this statement must be true. That is, D must be equal to D transpose. So, the original D, that is 1, 2, k minus 1, 2, 3, and 6. We have 2, 6, and negative 2. This is the original matrix D. Must be equal to matrix D transpose. That is over here. That is, we have 1, 2, 2, 2, 3, 6, and k minus 1. We have 6 there, and we have negative 2 here. Okay, this is our D, and this is our D transpose. Must be equal because matrix D is given the information that D is symmetric, a symmetric matrix. Okay, now let's compare between these two matrices, and we want to find the value for k. Now on the left hand side, we have variable k over here, and we have on the right hand side, we have k minus 1 over here. All right, so now let's compare correspondingly. Okay, this element is 1, 3, must be equal to the same position on the right hand side, position 1, 3 also, so must be equal to 2. So k minus 1 must be equal to 2. Therefore, k equal to 3. Okay, there you have it. The answer for this problem is k equal to 3. Now let's solve question number 8. A matrix B is an orthogonal matrix if B transpose is equal to B inverse. Okay, that's the statement must be true in order for a matrix to be an orthogonal matrix. Find the value of k if matrix A is an orthogonal matrix. Okay, given that this matrix here is orthogonal, an orthogonal matrix. Okay, meaning A transpose must be equal to A inverse, like this. This statement must be true. So what we have to do is we have to find one by one. Okay, we have to find what is A transpose first, you know, and then we find what is A inverse, and then compare between these two matrices, and then we can compare the elements inside the matrix, and then after that we can find the value for k. Okay, that's the strategy. Now let's find what is A transpose. Given matrix A is like this. So what is A transpose? Row become column, column becomes row. So column number 1, 0, 1 becomes row number 1, 0, 1. Column number 2, that is K0, becomes the second row, that is K0, like that. That is A transpose. Now to find the inverse of matrix A, first let's find the determinant of A. The determinant of A is equal to 0 times 0 is 0 minus k times 1 is k. So the determinant of matrix A is equal to negative k, like that. Okay, to find the inverse of A is equal to 1 over the determinant, that is 1 over negative k, multiply by, okay, 0 and 0, they are the same, because even if we change the position, it's still 0 and 0 also. Now k and 1, we have to multiply by negative 1, becomes negative k on this side and becomes negative 1 there. Okay, let's simplify this inverse, that is 0 divided by negative k, we still have 0. Negative k divided by negative k, we have 1. Negative 1 divided by negative k is, okay, we have negative 1, positive 1 over k, and 0, we still have 0 there. Okay, we have 0, 1, 1 over k, and 0. Now, since matrix A is orthogonal, okay, this statement must be true. So let's compare between matrix A transpose and A inverse. Alright, let's put them together. Okay, we say that A transpose must be equal to A inverse because this matrix is orthogonal. So A transpose is 0, 1 and K 0. And on the right hand side, A inverse. A inverse is, we have 0 there, we have 1 over here, and we have 1 over K, and we have 0. Now let's compare between these two matrices to find the value for K. Alright, the terms having K is at this position. That is, K must equal to 1 over K, right? K must be equal to 1 over K. That is, if we cross multiply, we have K square equal to 1. K square equal to 1. Therefore, if we take square root both sides, we will have K equal to positive and negative 1. Two answers, okay, for the value of K if the matrix A is an orthogonal matrix. Okay, guys, I hope you follow this explanation to find the value of K when given the fact that this matrix A is orthogonal. Here is question number 9. Find the value of K if the cofactor position 1, 2 is equal to negative 2. We are given this information and the matrix A is given like this. I hope you still remember how to find the cofactor of a matrix. Okay, it is given in this problem that cofactor at position 1, 2 is equal to negative 2. Okay, so what we have to do is we at this position, that is position 1, 2, row number 1 and column number 2. That is the, the position 1, 2 is not this number 1. So cofactor 1, 2 is actually equal to, what's left here is we have K there, and we have 2, we have 3 and 3. Now we still have to remember the what we call the sign, positive and negative. Positive, negative, positive, negative, positive, and negative. We have positive, negative, and positive. Now position 1, 2 is over here. Okay, we have to multiply by negative 1. So we have negative 1 outside. Is equal to, okay, the question is given us that this value must be equal to negative 2. So we have negative outside, we have 3K minus 6 supposed to be equal to negative 2. So negative 3K plus 6 equal to negative 2. Okay, we can continue solving this. We have 3K equal to 6 minus 2. That is 8. 6 plus 2 is equal to 8. Therefore, k equal to 8/3. Okay, that's the solution for this problem. K must be equal to 8/3 given the information that C, that is cofactor 1, 2, position 1, 2 is equal to -2, and matrix A is given like this: 1, 1, 1, K, 2, 2, row number 3 is 3, 3, 3, and we have a variable K at this position. Now, this is the last question for this video, that is question number 10. Given an SLE as the following, that is x plus y equal to 2, and the second equation is 2x minus 3y equal to 9. Two equation and two unknown. Now, it is given that the RREF, after we do the elementary row operation, is this one. This is RREF. RREF after we do row operation, But in this, okay, as you can see here, in this matrix, we have now, this is the last question, question number 10. Given SLE as the following: x plus y equal to 2 and 2x minus 3y equal to 9. Two equation and two unknown. Find the value for k if the RREF is as follows. We have identity matrix over here, and we have the right hand side, k 3, and we have 1 minus k. We want to find what is the value for this unknown k. What is the value for k? Okay, that's the problem, how to find the value for k. But, okay, we know from this RREF that we can, write down the solution from there. That is, we have x equal to 3, right? X equal to 3, and y is equal to 1 minus 1, y equal to 1 minus k. Okay, that's we get from this RREF. Now, the question is, we want to find what is the value for k here. One idea is that we can substitute the value of x equal to 3, the value of y equal to 1 minus k, substitute these two values into equation 1 or equation number 2. Now, let's do that. Let's substitute x equal to 3 and y equal to 1 minus k in equation number 1 and see what happens. X equal to 3, so 3 plus y is equal to 1 minus k, must be equal to 2. Okay, we have a very nice equation here, and we can solve for k. Alright, so 3 plus 1 minus k equal to 2. We have 4 minus k equal to 2. K equal to 4 minus 2. Okay, therefore k equal to 2. Yes, from first equation we get k equal to 2. Now let's check. For the second equation, that is 2x minus 3y, supposed to get 9. Okay, and we substitute again x equal to 3 and y equal to 1 minus k in equation number 2. That is 2 times x, that is 2 times 3, minus 3 multiplied by y. Y is equal to 1 minus k is equal to 9. Yeah, we have this equation now. Okay, let's simplify and then solve for k. So we have 6 minus 3 plus 3k equal to 9. Okay, 6 minus 3, we have 3 plus 3k equal to 9. 3k equal to 9 minus 3 is equal to 6, and k equal to 6 divided by 3 is equal to 2. Okay, we have k equal to 3 over here, and over here also we have k equal to 2. Okay, therefore it's confirmed that the solution for the value of k is k equal to 2, as we get it over here and we got it 2 also over here. Okay, class, that's all. All together, 10 questions all together, just as what we call revision for as a preparation for quiz number 1. Okay, that's all for now. See you next time. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.